Good evening, everyone. Welcome to this meeting of the Sacramento Valley
We have the
Astronomical
sound turned
Society.
off here.
My name is Raj Dixit. I've been a member for a long time. And tonight's presentation will involve some lesser-known deep space objects, gems of the winter skies. I'm going to
Okay,
share
we
my
can hear you now.
Am I coming through clear?
We can hear you now. Can you share your screen?
I'm about to, yes. I'm about to share my screen. Of course, Zoom is making it a little difficult. Here we go.
And I think you can make it full screen so we can close the participants.
All right, so how is that? Can everyone see the screen?
Yes, I can.
All right, yes, so winter is here. I did a previous presentation called Winter is Coming. Those were the most famous objects of the night skies. And because we're still at the height of winter, we have another month to go, I thought I'd do a follow-up, some lesser known deep space objects that are still gracing the night skies. So, oops. Ah, there's the winter sky as it appears on January 1st from Sacramento. The core constellations are, of course, Orion, Canis Major, Canis Minor, Gemini, Auriga, Taurus. But tonight's presentation, there'll be some objects, of course, from Gemini and Canis Major and such. But some of them will come from Eridanus, Lepus, uh, Cancer, and places where you don't look as often during the winter time. And we're also going to have some objects that you don't normally associate with the winter time. For example, globular clusters and galaxies. Globular clusters are generally considered to be summer objects, and galaxies are generally considered to be fall or spring objects. So we're going to get a smattering of very interesting objects that are a little different than what we usually see in winter, because what we usually see in winter are emission nebulae uh, and very bright stars. We're going to start off in Auriga the Charioteer. There's a map of it with and this chart, and this slideshow PowerPoint will be available upon request. I can convert the whole thing to PDF and send it out on request. There'll be star charts for every object discussed. This star chart will cover multiple objects in Auriga. I think I have 3 objects in the Auriga the Charioteer. This is the first one of them. This is NGC 1857, a very nice open cluster, about 19,000 light years away, with approximately 3 dozen members. The large orange star, however, is not part of the cluster. It's only in the line of sight. It's only 1,500 light years away and is not part of the cluster. Now, of course, the most famous open clusters in Auriga are the 3 Messiers, 36, 37, 38. But this is very close to matching them. It's quite pretty. It's quite nice. And it's well worth checking out. You can see it in binoculars. You don't need a telescope. It's well worth your time. It's a lesser known gem of the sky. The next object in Auriga, we have IC 405, IC meaning Index Catalog, which was a supplement to the NGC or New General Catalog. The 405th item in that catalog is this. It's called the Flaming Star Nebula. It's also known as Caldwell 31 or Sharpless 229. It's 1,500 light years away. And it would really help to have a UHC or an O3 filter because, like so many nebulae, it glows best in O3 or in a narrow band, in the narrow band region. So a narrow band or O3 filter will really help it bring it out, because unless you have crystal clear dark skies and very good aperture, it's difficult to see this without the use of a filter. If you were going to try, it helps to have large aperture and wide field, low mag, and an absolutely clear dark sky. And this is a planetary nebula. in Auriga. That's known as IC 2149 and nicknamed the Eye of the Charioteer. It's a relatively faint object at magnitude 10.6. So, in case for a little refresher, the higher the magnitude number, the dimmer it is. And so the limit of naked eye visibility is 6. The brightest star, Sirius, is minus 1.4. Venus, which is extremely bright now, is minus 4. A full moon would be minus 12. Uh, and then for every one number, it's 2.512 times a difference in brightness, which means that 5 is 2.512 times brighter than 6. 4 is 2.512 times brighter than 5. Uh, on the other hand, 7 is 2.512 times dimmer than 6. In case you're wondering why 2.512, uh, it's so that every 5 magnitudes you go up, I believe that makes it 100 times the difference. Uh, the difference in brightness. So this is a very nice planetary nebula, a star much like our sun that reached the end of its useful life and then shed its layer of skin and shed its layer of gas, like same way a snake sheds its skin, leaving behind a white dwarf and an ever-expanding shell of gas. This was discovered in 1906 by Harvard astronomer Williamina Fleming, who discovered it while scrutinizing the photographic plates that were in the archives at that time. This object is roughly 3,600 light years away. Moving on to the constellation Cancer, which is, some people call that a spring constellation. It is visible in winter, especially now late winter, because especially after midnight this time of year, even though we're still in winter, after midnight, especially toward 1 a.m. and thereafter, the winter constellations are setting, and the spring constellations like Leo and Cancer are clearly visible and pretty high in the sky. So I decided to include this one object from Cancer. Uh, it's a 65 million light year away spiral galaxy, a flocculent spiral. It's part of the Virgo supercluster along with a local group. It was discovered by William Herschel in 1783. And this galaxy is the centerpiece of its own group called the 2775 group, which is similar to our own local group and is also, and along with our local group, is part of the Virgo supercluster. Here's where it is in the sky. You see Cancer up there with a famous beehive or Praesepe, Messier 44. Leo, the bright star of Leo, is Regulus. It's right on the border with Hydra, but it is still technically within the constellation boundaries of Cancer. So it would be just to the northwest, sorry, east of Omega Hydrae. This amazing object is NGC 2207 and IC 2163, which are colliding spiral galaxies that happen to be located 80 million light years away from us. And when you look at it through a telescope, you will see the two nuclei, and they appear to be just two galaxies. It would take very high aperture to see the arms, but it is a striking object in a telescope. This is a Hubble image. And to make it even more interesting, that's a James Webb image of this seen in infrared. Cuts through a lot of the gas and dust, brings out some of the star-forming regions, and brings out the inner structures of both galaxies. And the pair are located basically between Canis Major and Lepus. I think technically it is within the bounds of Canis Major. So It's a remarkable object, and again, uh, too many times, even amateur astronomers like me have made this mistake. In wintertime, we get roped into the Orion Nebula, the Rosette Nebula, the Horsehead Nebula, maybe M79, the Puppis clusters, M46 and 47, all the Messiers. And there are so many objects in the winter skies that really deserve more scrutiny and deserve more attention, and that's what we're trying to highlight here. The next one will be in the constellation Cassiopeia, which is at its peak in the fall, but it's still very visible in wintertime. It's technically a circumpolar constellation, so it's almost always visible. There are times when it gets very low to the horizon, but even as of right now, it's still pretty high in the sky. And there are, of course, Messier and other open clusters in Cassiopeia, but this is a very bright one that's just as good as any Messier open cluster in Cassiopeia. NGC 663, or Caldwell 10. It's a young cluster, has an estimated 400 stars, and it's about a quarter of a degree across the sky. There are reports that this can be seen with the naked eye from a very dark sky. I have a hard time believing that. It is true when you look at Cassiopeia from Blue Canyon or darker skies, you can your averted vision, or more likely your averted imagination, might see some fuzzy patches of light, which correspond to the open clusters there. But I think that's more of a case of you want to see it, so you think you do, rather than actually seeing it. Uh, Easily seen in binoculars, but a small telescope with a wide field eyepiece would bring out the best view. Uh, this is about 6,800 to 6,900 light years away, and estimated to be 20 to 25 million years in age. Open clusters, of course, are young stars that are all born out of the same gas and dust cloud, and thus they retain, in their infancy and youth, close proximity before they're eventually dispersed and scattered into the arms of the galaxy. And there it is, 663. If you look at the W of Cassiopeia and look at Delta Cassiopeia or Rukaba, it would be to the east and slightly to the north. Or you could look at Epsilon Cassiopeia and drop almost due south if you could. And that'd be the way to find it. Moving on, and there's just so much to cover because we are literally talking about the infinite universe. But the next object in our treasure chest is this, a galaxy. Again, we don't often associate galaxies with wintertime. We usually think of galaxies as fall and especially spring, but there are a wealth of galaxies that can be seen in winter, and this is among the more striking of them. It's NGC 1808 in the constellation of Columba, Columba the Dove, which never rises that high in the sky, unfortunately, here in the Sacramento area, but it does get high enough that you can see this object. You need a dark sky and hopefully a flat horizon. But if you're at Blue Canyon and facing due south, that's owing to the fact that the runway opening out over the valley, there is a fairly flat horizon, and that's your best chance of spotting it. It was discovered on the 10th of May, 1826, by Scottish astronomer James Dunlop, who described it as, quote, a faint nebula, end quote. Pretty much everything in those days through a telescope was a faint nebula, no matter what it was, whether open cluster, globular cluster, emission nebula, or galaxy. It's a member of its own group. It's the core of its own group of galaxies called the NGC 1808 group, which is part of a larger group of galaxies called the Dorado group, which would be hard or almost impossible to see for us, as Dorado is primarily a southern hemisphere constellation. It tells you how low in the sky this is. Uh, it is visible from Sacramento, but it's a southern object, roughly 42 million light years away. And yeah, you can see Puppis. There's Columba, Alpha Columbae. You would go west and slightly south. So it's between Columba and Eridanus, the river. As you see, it's very close to Horologium, which is very difficult to see from us. Puppis. We can see parts of Puppis from Sacramento, but uh, there's a Pictor, the easel, and that's basically primarily a southern constellation. This is hard to see. It is doable, but it's hard to see from our latitude. Coming up next is a globular cluster, which again, you don't see a lot of globs in wintertime. We basically think of them as summertime objects, mostly all in Sagittarius and Scorpius, and except for the Hercules and the summertime constellations. This is also known as Caldwell 73. It's a massive globular cluster located again in Columba the Dove. Astronomer John Dreyer, who was responsible for compiling the New General Catalog, described it as not very bright, but very large, round, well resolved, and clearly consisting of stars. It's located about roughly 40,000 light years away from us and about 54,000 miles away from the core of the Milky Way. It has a highly eccentric orbit around the galaxy. It's estimated to be just over 9 billion years old and 551,000 times the mass of the sun, if you added up all the stars inside together. Uh, and quite frankly, I'm looking forward to getting out there and finding this because the only winter glob I could think of off the top of my head were M79 and Lepus, which I've covered. And there is another one coming up later called the Intergalactic Tramp or Intergalactic Wanderer in Gemini that I have seen, but I don't think I've spied this yet. I'm going to have to look for it my next outing. And here's how to find it. Again, on the southern edge of Columba. So it would be possible to see. It would be very difficult. As you see, Pictor, Coelum, Carina, Canopus. Pictor is right on the edge of visibility. Canopus is something you can't see it from California. I've seen Canopus, but I was in Playa del Carmen, Mexico, much farther south. And there you can get a good view of it at this time of year. But this would be a lesser known gem of winter that I'm going to have to look for. Here is NGC 1300. It is a barred spiral galaxy, 65 million light years away in the constellation Eridanus, the river, which is basically underneath Orion. About 110,000 light years across, so roughly the same size as our own Milky Way. Although our bar is not that pronounced, even though we are a barred spiral as well. It's a member of the Eridanus cluster, which consists of about 200 galaxies. NGC 1300 itself is in a subgroup of about 4 galaxies and it's the core of that group, which is called the NGC 1300 group. This was discovered by John Herschel in the year 1835. To find this galaxy, this one I have seen. It's low in the sky, but it's in Eridanus, and it's to the east of Cetus. It's above Fornax. And Fornax is, again, it's visible from Sacramento, but it's low. So this is, again, it helps to have, you don't want to be around any tall trees. You want to have a flat horizon to find this puppy. But you can do it. It is doable. It helps to have a aperture. An 8-inch dot will do it, but 10, 12 would be preferable, and 16 helps a lot. When it comes to telescopes, size does matter. And there's no substitute for aperture when it comes to these faint fuzzies. So here we go. And this next object is the large galaxy is NGC 1532, and the small one is NGC 1531. 1532 is an edge-on barred spiral. And these two are about 50 million light years away from us. They were discovered by James Dunlop on the 29th of October, 1826. And the larger one, 1532, is believed to have several dwarf galaxy companions. It's obviously very clearly interacting with 1531. The tidal forces have created these unusual plumes of stars right above the disk, as you can see here. This This is kind of like the Whirlpool galaxy, M51 and NGC 5195, if they were viewed edge on rather than face on, the way that M51 does appear to us. Uh, and this is an outlying member of the Fornax cluster. And again, with Fornax being a very southern constellation, this would be low in the sky. I have seen it. It is kind of tough to see unless you have an unobstructed view of the horizon, but it is doable, and it's definitely worth your time. Again, it's in Eridanus, but it's below Lepus and just above Columba. So that gives you an idea of how low in the sky it is. Uh, Again, right below it is Horologium, the clock, which is the southern constellation. You don't see it from our latitude. Uh, and it's even below, it is to the east and slightly south of Alpha Fornacis and Fornax. So it's low, but it is possible, and it's well worth seeking out. And here is NGC 1535, a very lovely planetary nebula. It's in Eridanus, and it's nicknamed Cleopatra's Eye. It was discovered by William Herschel on February 1st, 1785. It's similar to the what used to be called the Eskimo Nebula, or now called the Clown Face Nebula in Gemini. It has a similar structure. The central star can be very hard to see. I don't think I saw it even in a 16-inch, but definitely see the double ring effect. It's one of the Herschel 400 objects, and at the center of it, it's believed that this was once an O-type star. Okay, and the total distance to this object is about 6,500 light years. And this is a little bit high. It is in Eridanus, but it's about on par with Rigel. If you go to Rigel and go almost due west, so it's not as difficult as some of the preceding objects. It's not going to get that high in the sky, but Orion does get to a decent height, and Rigel gets to a decent height. So you can spot it if you have a good, clear, dark sky. Okay. Now, this lovely object is called the Robin's Egg Nebula. It's another planetary, NGC 1360 in Fornax. I have seen it. It's hard to see, but you can find it. It really helps to have a UHC filter or an O3 filter. And the central star inside here was believed to be a binary. And they thought that since 1977, but that was only confirmed through more recent observations in 2017. And the center, there's a low mass O star and a white dwarf. And the masses of those two objects are estimated at basically 3/5 and 7/10 of a solar mass, respectively. This was discovered in January of 1868 by a German astronomer, Friedrich August Theodor Winnecke. Winnecke is also known for some double stars and other miscellaneous deep space objects. And its planetary nebulas are notoriously hard to pinpoint in terms of distance because it's not as easy to triangulate or see redshift the way you would with galaxies or brighter point sources. So distance estimates range from anywhere from 1,150 to 1,800 light years from us. And my PowerPoint has frozen up again. I'm trying to go to the next. Here we go. Get to the next slide. Again, it's a little lower. It's sort of between Rigel and Sirius, heading west. It is in the core of Eridanus, and it's hard to see, but you can do it. Helps to have a. Sounds almost repetitious, but can't be said enough. Clear, dark sky. That's what you need to find to be successful in hunting for DSOs. This is one's a treat. I have seen this. It's called Hubble's Variable Nebula. Uh, it's basically a reflection nebula illuminated by the light of the star R Monocerotis. This is in the constellation of Monoceros the Unicorn. This was discovered by, first image, most famously imaged by Edwin Hubble back in 1949, January 26th, using the Hale telescope. Uh, and it varies in brightness. And one of the explanations for that is believed because we think of stars as variable. We never think of nebulae as variable. But the varying brightness of the nebula is that the dense dust clouds, perhaps they periodically block the central star, uh, which then becomes, and the central star here is not this. The central star here is so completely obscured by the dust, it's not visible itself. Uh, but the central star is adding to the reflection uh, from Armonocerotis. Uh, and so periodically the dust clouds seem to block it off, which would contribute to the variable brightness of the nebula itself. The magnitude is ninth magnitude object, meaning dim, of course, far below visible light. I'm sorry, visible naked eye visibility. Yet 9 is pretty easy for a telescope. Any telescope of 6 to 8 inches or higher should be able to spot this object. It's roughly 2,500 light years away. Now, as a treat, there is Hubble's original image of this object taken with the Hale telescope in 1949. And that's where the object is. So yeah, this is kind of higher in the sky, which helps. It's basically you head east from Betelgeuse, slightly to the north. Between Betelgeuse and Procyon and the Little Dog, you'll find Hubble's Variable Nebula right in that region. And just south of the foot of one of the twins of Gemini, of Pollux, actually. Uh, this lovely object, our next one, is appropriately called the Butterfly Nebula. It's NGC 2346 in the constellation of Monoceros. It's another planetary. Its magnitude is 11.6, so you'll definitely need a telescope. It's roughly 2,000 light years away, and fortunately, a telescope, one with some pretty decent aperture. 8 inches could probably do it on a dark enough night. I would be more comfortable with 10 or 12 or more. The central star is a spectroscopic binary with a period of only 16 days, remarkably. And it's a variable star, but the variability is believed to be caused by dust orbiting around it. And it's 4,760 light years away, according to our best estimates. And here it is. It's in Monoceros, which is to the east of Orion, north of Canis Major, south of Canis Minor, closer to Canis Minor than Major, and basically between the three belt stars are, see my cursor, Alnitak, Alnilam, and Mintaka. It's almost due east of Mintaka. The closest star would, of course, be Delta Monocerotis right there, or you just go southwest of Procyon if you want, or make a very highly acute triangle with Procyon, Betelgeuse, and this object. Our next lovely object is NGC 2266, an open cluster. It looks kind of like a triangle or a tree. It is in the constellation Gemini, discovered by William Herschel on the 7th of December, 1785. Its magnitude is 9.5, so it's on the edge. You could probably do it in binoculars if skies were dark enough. A small scope with a medium power will bring it out quite well. A medium scope at low power will give you a very good view. The angular size is about 5 arc minutes. Any amateur telescope with good skies and good optics can resolve individual stars in the cluster. It's between 10 and 11,000 light years away, and it's located to the opposite part of the sky from the galactic center. So it's the galactic anti-center from our perspective. It's about 16 light years in diameter, and is estimated to be 81 million years in age. So it's getting kind of old for an open cluster. And there it is. It's If you look at Epsilon Geminorum and go almost due north, or goes not due south, but mostly south and slightly west of Theta Geminorum, you'd find it. Now, this is Sharpless 2-274, the Medusa Nebula, a large planetary located 1,500 light years away. It's also in Gemini. Now, this is magnitude 15.99. That's almost as dim as Pluto. So this is very challenging because I've seen Pluto in my 16-inch Dobsonian, and it may be the hardest thing I've ever had to see. It is very dim. This being a planetary and more dispersed, Pluto is at least a point source. This would be very, very difficult. Uh, it spans about 10 and a quarter arc minutes across the sky, and it's physically 4 light years across. And perhaps the best photo ever taken of it was taken at the European Southern Observatory, which, of course, they use the RGB, sulfur line, oxygen line, uh, and they can really bring out the Medusa-like appearance. As you recall from your Greek mythology, Medusa was the lady cursed to become so horrifyingly hideous that anything she looked at turned to stone. Her hair became snakes. You can almost get a sense of that by looking at this image. Moving right along. And so it would be northeast of Procyon, almost drawing, if you drew a line between Procyon and Pollux, and then went slightly north of that line, okay, and south of one of the legs of the twin and Pollux, then you'd be able to locate it there. It is high enough in the sky that you don't have the concerns of some of our previous objects. It's never going to be at zenith or anything close, but it does get high enough to be visible if the sky is dark enough. Continuing, we have this barred spiral galaxy in the constellation Lepus. So again, that's underneath Orion. And again, a wintertime galaxy is always a treat. 1964 is a barred spiral, 65 million light years away from us, and is believed to be about 100,000 light years across, so more or less the same size as the Milky Way. At its center lies a supermassive black hole uh, with an estimated mass of almost 275 million solar masses. And NGC 1964 is the main galaxy in a group. It's the core of that group, so it's called the 1964 group, which includes at least 3 other galaxies visible in amateur telescopes. And again, here is Orion, the mighty hunter. It was apparently stalking Lepus, the rabbit. And I do like this stellarium rendering of Lepus because it actually does draw the lines in such a way that it looks kind of like a rabbit. So this is going to be low in the sky, but not impossible because as you can see, Sirius, which is definitely visible from our latitude, it is to the northwest of Sirius, mostly west, more west than north, but it is high enough to be seen. If you were to draw a very long triangle with Rigel and Safe from Orion, that could help you star hop your way to it. At magnitude 10.8, it's dim, but doable in a telescope of medium to large aperture in a good sky. And here is IC 418. We're staying in Lepus the rabbit, or the hare. It's a planetary nebula, nicknamed the Spirograph Nebula because it has an intricate pattern. The spirograph, you remember those drawing tools that you may have played with in your younger days. This Hubble image really brought out the intricate details, and it was after this Hubble image was published that this object acquired the nickname of Spirograph Nebula. The magnitude is 9.6, so dim but doable. It's about 3,600 light years away from us, and about a third of a light year across. Several thousand years old when the central star, a red giant at the time, slewed off its outer layers, having reached the end of its life, and ejected any remaining material, and leaving only a white dwarf at the core, which is going to happen to our sun billions of years from now. Uh, at least 6 billion, probably maybe a little bit more than that, but it will happen eventually. And as the white dwarf cools down, as these blown off shell of gases cool, they will slowly disperse into surrounding space. The white dwarf will persist for literally another 10 billion years or more. And IC 418 this is the best Pilot chart I could locate for it. It's from WikiSky. It's underneath Orion, as Lepus is, almost between Rigel and Safe. And this is a close up here. The inset shows the constellation, some dim stars in Lepus, and it's to the east of this small quadrilateral four-sided object in asterism in Lepus. There's your bullseye. And this is a fun object. I have seen this one. It's the NGC 2419, called the Intergalactic Wanderer. That must be the politically correct term, because when I first read about it, they called it the Intergalactic Tramp, which just has more flavor, in my opinion. It's a globular star cluster with a visual magnitude of just over 9. So again, not naked eye, of course, but not especially dim. Any decent telescope should be able to see a ninth magnitude object, particularly a bright point-like source of light as a globular cluster. It's a Shapley Class 2, meaning it's very concentrated at the center. It got its nickname because when first discovered, it was believed that it did not orbit the Milky Way. It was believed to be merely traveling through intergalactic space. That's been proven false. It does orbit the Milky Way. It's a 3 billion year orbit. It's 300,000 light years away from the center of the Milky Way, about 275,000 light years away from us. It is one of the most remote globular clusters. Actually, it's twice as far away from the center of the Milky Way as the Large Magellanic Cloud is. It was discovered by William Herschel on December 31st, 1788, and it was originally believed to be a star. It was Carl Lamplin, an American astronomer, who discovered it was really a globular cluster. Now, if you're searching for this object through a telescope, I have seen it. The telltale sign is these two bright stars. They will be in the same field of view through your eyepiece as this object. And so, in case you're thinking you might be seeing another glob, or maybe a coarse cluster, or some sort of other object, this is the tell. That bright pair of stars right there. And here's the intergalactic tramp. That's what it should be called. As a name with a little bit more flavor. Basically, due north of Castor in Gemini, it is still within the boundaries of Gemini. Actually, no, I'm sorry. It's in the constellation Lynx. It's you see it. The closest bright star is in Gemini, but it is technically in the constellation Lynx, which is a very dim constellation. So using Castor or Alpha Geminorum, that would be you would begin your star hop there rather than beginning in Lynx. Now, staying in the constellation Lynx is NGC 2683. This is an unbarred spiral galaxy near the edge on. Visual magnitude about 10.6. It's about 25 million light years away from us. It has a nickname of the UFO galaxy, which I think you can tell how it got that nickname just by looking at it. Although the nickname was bestowed by the Astronaut Memorial Planetarium and Observatory and discovered by William Herschel. Isn't that a recurring theme? The greatest visual astronomer that ever lived, William Herschel, aided by his sister Caroline, discovered 5,000 objects, and he's the one, they laid the foundation for the modern NGC catalog. This galaxy, sadly, is like so much of the universe receding. It is moving away from us at the speed of about 918,000 miles an hour. So go see it while you can. And the way to do it is, again, it is in Lynx. Lynx is not very bright. Well, you would find Alpha Lensis and go west and slightly south, or almost due east from Castor, Alpha Geminorum. Uh, and yeah, probably between the two alphas, Alpha Lensis and Alpha Geminorum, closer to Alpha Lensis, of course. Try to draw a line between the two alphas, and then drop ever so slightly south. Last up, I don't know if you can see it on camera, but I'm wearing a shirt that shows my alma mater, Cal Berkeley, the University of California, Golden Bears. And this is called the Bear's Paw Galaxy, NGC 2537, or ARP6, from Houghton ARP's catalog of peculiar and unusual galaxies. This is a blue compact galaxy. It's a small galaxy that contains large numbers of hot young stars, hence the bluish color. Large young stars are almost always bluish, blue supergiants, and that gives this galaxy a bluish tinge. It has a visual magnitude of just over 12, so it can be a bit of a challenge. But it was discovered on the 6th of February, 1788 by William Herschel. What a surprise. And estimates vary, but the consensus is somewhere around 23 million light years from Earth. And again, if you were looking for it, again, go almost due east, and then slightly south from Castor. Or also, you can use the pointer stars in the bowl of the Big Dipper as another landmark. If you drew sort of a T angle or cross section, you would look for it in that vicinity. Or you could form a triangle between because the Big Dipper is an asterism in the greater constellation of Ursa Major, the Great Bear, the bear's nose and front paws being there. If you try to triangulate between the two, although these stars can be harder to see unless you have very clear, dark skies. But the object, at least it'll be high enough to see, especially at the height of winter. This is not going to be blocked out by trees. And you won't be able to use, the dust and smog near the horizon as an excuse for this one. Now, I haven't seen this one. I had to put this on my to-do list. I've seen quite a few of the others, but not everything. This is definitely going on my next trip to Blue Canyon when the snow clears, or Black Butte, or wherever. This is definitely going on the list. All right. Thank you very much, ladies and gentlemen.